Now we have Kevin Olsen. He is engineering lead at Gitcoin DAO. He will talk about Sybil resistance in Web3. Let's welcome him on stage.
Cool. Thanks, man.
Thank you.
All right. Cool. Hi, everybody. So I'm not Kevin Owaki. I'm Kevin Olsen. So I kind of feel like this is the sort of the can we get Kevin to speak at our conference? Meme, mom, we've got Kevin at home. Kevin at home. Kevin couldn't make it, so I'm going to do my best to step in. But yeah, big shoes to fill. So maybe to get started, who knows about Gitcoin grants? How many of you used it? Yeah. Who's made money with Gitcoin grants? Anybody here gotten funded? Yes. All right. Cool. Yay. What I'm going to talk about today is Sybil resistance. So there's kind of a problem, right, in this space that we've solved through, some inelegant methods. But we want to kind of characterize this, like what is this Sybil resistance issue, why it's a problem, so we'll kind of go through that. Talk about how it's, you can kind of think of it as this game, right? And we'll give you the characteristics of the game, and then we'll propose a Sybil resistance money Lego. So to get started, oh, my slides aren't moving, that's okay. If you want to play along at home, you can go to wtfisqf.com. That's a site that we run. You can play with QF. If this was moving, what you would see is a match amount at the top, right there. That's like the matching pool in Gitcoin, right? And quadratic funding, as you add funders to that, you'll see that the votes are distributed not evenly, but quadratically, meaning many small votes actually brings a much larger match than one large vote. So apologies, this is a PDF and I'm not getting the animations there. You can kind of get the sense that what happens is really big votes, really large single votes, the kind of impact is attenuated, right? So this is a close kind of sibling to quadratic voting. But in quadratic funding, what we're doing is we're taking in these votes are the voice credits in the system are the individual donors' donations, right? Your vote to support a particular project is matched out of the matching pool, but it's summed with all of the others in the voting system. In Gitcoin, we've raised and distributed $65 million. And this is a network graph. So every dot here is a donor, and every line is a transaction. What's super cool about this is the original ones were pretty sparse, and now you can see this is a very dense network of donations. But this is the problem. So again, if these were moving, what you'd see is this donor at the top with their 10 $1 donations is dragging much more funding to their project, right? Now, if I want to drag more to my project, what stops me from generating 20 accounts for myself, right? 20 sock puppets, and I can steer way more funding back towards a project, which maybe I control. And this is the problem that we see. We see people putting in grants that they control, setting up these sock puppet accounts, and distorting the output of our system. But beyond just Gitcoin, there's a really cool opportunity here, which is we can start moving into more one human, one vote type systems, right? If we had Sybil resistance. So here's the kind of prism, right? So with Sybil resistance, you can get into quadratic funding, right? We need that for our system. You can get into quadratic voting. You could maybe do things like UBI, right? And data collectives and some really interesting stuff that allows us to move away from what are essentially, in the system, plutocratic methods of decision making, right? So actually honoring true wisdom of the crowd decision making. So, okay, I think we get a sense of like why Gitcoin needs this and why other systems need it. So why is this a Sybil resistance game? We talk about this at Gitcoin in terms of a red team and a blue team, right? This is kind of like, I think, security parlance. The red team are the bad guys, and the blue team are, I guess, us, in this case, or the parts of the DAO that try to not have these effects distorting the outputs of our quadratic funding rounds. So who are they? So there's just script kiddies, right? There's just people who are kind of in it for the lulz, who are trying to like impress their friends. You have petty criminals. You have people who are just trying to see if they can exploit the system. Then you get into like rational economic actors. And this is a really interesting one, right? Because these people aren't really doing anything wrong. There's funds that they can get. There's airdrops they can farm. They're doing their best for themselves, but they found a way to exploit the system, right? They can create a bunch of sock puppets. They can try and distort this and drag funds to their projects. It was a lot of DeFi depth. If you followed this one, this guy stood up like a whole DeFi ecosystem. Whatever. Not our problem, but maybe somebody else's. You've got organized crime, people with more resources, potentially bigger goals. And then you have like nation states, right? You have people with potentially unlimited resources, right? So imagine you're building some very large systems. You could very easily lose to these folks. So now, how is this a Sybil Resistance game? So what are the characteristics of this game, right? And why propose it as this is because we want to kind of propose a solution to it as well, but it's important to think about you can't just go after this with a single idea, right? So one of the things that you've seen, maybe some people claiming they've solved Sybil Resistance, is you get into some pretty dystopic solutions. So let's try to avoid that by characterizing the game. So the most important thing is criteria 0. It's an adversarial game, right? So if there are funds to be captured, someone's going to try, right? Someone is going to try and exploit that. They could be a rational actor, or they can be, as I said, actual bad guys, actual criminals. So, okay, it's adversarial. We can't get around that. Step 1 here is the need to be privacy preserving, right? You can't, well, you could, right? You can see these biometric approaches. You can build a centralized thing here. But ultimately, what you want to do is make sure that people have their own data, right? We love giving our data away for free, right? Don't we? We all love just giving our data away to Google and Facebook. I think we're here because we don't want to do that. That's why I'm here. So I think for a design solution, you need to make sure that's privacy preserving and that people have data sovereignty, right? That they control their data and they control where it goes. Step 2, right, is avoiding plutocracy, right? So this is the token voting that we're all pretty familiar with. It kind of works in this adversarial environment where people with the most tokens probably have the most investment in the project. Maybe you can kind of draw that out. But it's a kind of economic gatekeeping, right? And you're really trying to source the wisdom of the crowd where many people who don't have a lot of funding can steer things like Gitcoin grants. You need to have something other than this, right? So you can't just gate on tokens, I think, is a long-term solution to the game. Collusion. This one's a harder problem, right? So what stops me from bribing you to use your identity in a voting system? There's some technologies, you have Macy, right, where you can make it hard to prove that the person who was bribed did the thing that the briber wanted them to do. But ultimately, I think some of the better proposals here kind of come from the DSOC paper, right, that Vitalik and Glenn and Pooja wrote. That one's interesting because it kind of sidesteps the problem and says all coordinated actors are colluding, and let's just sort of take that as the premise. But in general, collusion is a very difficult thing to look at from just an individualistic approach. So step 4, you need to build in systemic defensibility. So I think this is a good one where, if you think about the way we secure chains, it's economically incentivized, or maybe the risk reward is better to use your mining hardware to mine than to attempt a 51% attack, right? So you can build a system that incentivizes systemic defensibility. And if you want to drill in, though, so this is this Gitcoin grants round 1, completely wide open. Anybody can show up. End users, you have the red mixed in with the good actors, quadratic funding, grants, and 25K in matching. But where are we now? We actually have a number of kind of places. So this is where we're sort of defining the battleground, right? We've got grant reviews now, right? So grants go through a review process. We've got reviewers, right? That's kind of the blue team there. Then you've got the ability for those grants to get through the approval process. And then you have Passport, which is a product I'll get into in a little bit, and so other DApps in that ecosystem, other identity providers that help us to kind of sort out who's a human. And then we used pairwise QF, which is another way for us to attenuate forms of collusion, and to add things like the trust bonus, which we added a few rounds back. And ultimately, that is the gate onto the grant. So we've kind of got our points of control here, and other systems would need similar ways to sort of intervene. So step 5 is building network effects. What I like about this one, actually, I think if you look at this, if we've all read Impact Networks, I think, by Ehrlichman, I think we're kind of somewhere in the stage 1 to stage 2 phase, right? Where you have lots of projects that are attempting to solve Sybil humanness, proof of personhood type problems, but they're all kind of disconnected. They haven't really been integrated. So we're in the phase now, we're trying to kind of pull that together into a hub and start providing some way of aggregating these signals and to build some kind of community around that. But then we also want to make sure this is a multi-hub approach, and then ultimately you get into this kind of core and periphery where you get the real sort of effects of that network, all contributing without a single point of control or single point of failure. I think kind of piggybacking on that same thing, you have modularity and forkability, right? So anybody should be able to iterate on this permissionlessly from the edges. Kind of goes into the open source ethos, VidiEyes makes any problem shallow. I think that that's an important design criteria. If you're not interested in that, then I think this is maybe a bad community for that too. And then obviously decentralization, right? So getting into this idea where there's not one project that controls this or one community that controls it. And lastly, I think the important thing here is that this is an evolutionary game, right? As the red team gets more sophisticated, we need to make sure we have tools and that we're thinking about evolving our system as well, right? That we need to make sure that we're working to solve this, right? So where we are now, like the feedback cycle for Gitcoin is kind of quarterly, right? We run our Gitcoin rounds, we look at what happened, were the signals distorted, or did we find fraud at the end? You can do like an end analysis. But then we need to also be doing this daily group. So we have the FDD inside the Gitcoin DAO, which does real-time kind of monitoring of this, and then again, instant feedback. So you have to have these signals kind of nested within your system. So then lastly, here's the proposal, all right? What will grants round look like in around 16? That's an Iwaki joke. Nice. Is it needs to be anti-fragile, right, to many types of attackers. You have your script kiddies all the way up to nation states. You have to be ready to be resilient against all of those things. It needs to be privacy preserving, right? We can't be harvesting this data. We can't be concentrating it. I don't really want to run a system that's a honeypot to dox people, right? So we need to make sure that we're designing this openly. We need to be avoiding plutocracy, right? If we're designing systems, they're supposed to be democratic and surfacing the wisdom of the crowd. We can't just fall back on token gating. We need to avoid collusion. Like I mentioned, there's like open design space there and some really interesting things to do. This system has to be anti-fragile because it's cheaper to defend than attack. That goes back to that systemic defensibility, right? The cost of attacking the system is too high to be economically feasible. The network of effects of open source, enabling the innovation, preventing capture. And then lastly, that we need to make sure that we can't just say this is a one and done thing, right? There has to be a place for this to continue to evolve. So what have we built? We built Passport. The docs are there if you want to play with this or if you're using it in Gitcoin grants round 15, which is running right now. You can go to passport.gitcoin.co. What this is, it's an aggregator, right? So you can sign in through a variety of systems. You can attest to your activity on chain. And we use that as a way to then you can feed that passport back into Gitcoin and get your trust bonus score. So this is part of one of those blocks there where we're attenuating the signals of bad actors or people who can't prove their personhood by looking at that uniqueness of all of these signals. What we've chosen to do here is to make sure there's no PII in any of these stamps. So we're using the DID and VC approach. Check it out. It's all open source. There's an SDK. Feel free to play with it. And that's it. Thank you.